My name is Alan Kamaliki, and I'm going to show you how to design a road using Civo 3D. First, I'll show you how to process the survey data before I import it into Civo 3D. Here is my survey data in Excel form. As you can see, it has been arranged into 5 columns. The first column is the point number. The second column is the northing, the easting, the elevation, and the description. First, I'll have to remove the elements from the data that cannot be interpreted by Civo 3D. The first row, I'll have to delete it because it contains letters and columns that are not supposed to contain letters. So I delete that. Then I'll remove the borders. Civo 3D can't interpret borders. And then the description. You have to make sure that you understand the descriptions in your survey data. You can get that from your surveyor. So here are my descriptions. As you can see, there is CL, which means center line, RE, which means road edge. There is the drain, there is the island, and such. Now I'll save the data in a format that can be imported into Civo 3D. I usually love using CSV, comma delimited. So I'll save it in form of CSV, comma delimited. Where is it? Here. So I'll save it on my desktop. Then I'll close this. And now I'll open my Civo 3D. First, I'll have to import my data into Civo 3D. My data is point data. So I'll right click on point data, then create. Then here, import my survey data. So the data has been accepted, and now I have to choose the format in which the data was arranged. If you can remember, the row I deleted, it was arranged in this form. It was point, northing, easting, Z for elevation, and D for description. So I'll choose that, then OK. So let me zoom and see if my data has been successfully uploaded. Zoom extent. There it is. So this is my data. This is the point data. Let me delete most of it because I only want a small section. Let me delete that and remain with this. This is what I'm going to use. So I'll have to create point groups to make my work easier. I'll have to create point groups. The first point group is the center line, which is the most important. So I click here, point groups, right click, new. Let me name it center line. And this point group should include points with row descriptions matching CL as it was in my data. So there we are. Another point group will be the road edge. New, name it road edge. From my data, road edge header description RE. So there we are, road edge. Then let me see. Island, there's island. Should include descriptions with ISL. Then there is kilometer 0 plus 000, which includes description 0 plus 000. I think that is enough. So here is now, after creating point groups, I love to create the surface. So I come to the prospector. After point groups, there's surfaces here. So I right click on the surface, create surface, then let me name it Road 1. So my surface is called Road 1. And here is the surface. Let me define the surface. From Road 1, you click the plus icon. It will open another list of headings. There's definition, there's point files, point groups. So I love to add the groups that I want to be included in the surface. In this case, I'll add all the points and apply. As you can see, it has created a surface here with contours. Now, the next step is the most important step in road design. It is the creation of the alignment. It is the most important because you have to adhere to all the standards they require. Depending on which country you are in, you have to adhere to the standards and specifications that the country uses or you are supposed to use in drawing the alignment of the road. So in this case, I'll be using the road design manual, the Kenya Road Design Manual mostly. Those will be my guiding standards, and I'm going to draw an alignment for a road that has a design speed of 90 kilometers per hour. So my curves will have a minimum radius of 450 meters. That is according to the road design manual. They create constraints because it is an existing road, so I don't have to go. The center line doesn't have to go so far away from the road edge. So to declutter my drawing, I love to select the elements that I want, then isolate them. In this case, I need the centerline points, which I will select by right-clicking on the centerline, then clicking select, and the road edge points. I'll do the same. Then I'll type in the command bar isolate. So I think it is still very cluttered. Let me remove the road edge. Let me select the center line only. Isolate. And To declutter further, I remove the descriptions and definitions from my points so that I only remain with the points themselves. So properties, I remove the point label. Let me remain with the description only. Yeah, that way it's better now. So here is my center line, and now I want to create my alignment. I'll call my alignment rod 1 alignment. These are center line alignment proposed. So there we are. So to draw my alignment, I prefer using the 3-point fixed curve to draw my arcs. That is the best. So the first section from this point to that is actually a straight line. So first I'll draw the straight line. Let me put a snap so that, yeah. So the first section is a straight line. Then there's a curve. It's a perfect curve. So I'll do that. I'll select my second point, and with the third point I get that perfect arc, just like the center line guides. And I click enter. You realize once I click enter, the chain edges join. The chain edges of the first part of my alignment and the second part join, and they make a continuous sequence. But when you zoom where the two lines join, there is an exclamation, meaning there is an error. The point of inflection is not smooth. So to smoothen this point of inflection, I'll have to put another curve, to make another curve here, a small curve here, so that the point is not. So let me smoothen the curve. I'll select a free curve fillet between two elements using a radius. So after I select that, I click on the first part of the alignment. I click on the second part. The angle should be less than 180. It is a reverse curve because it constitutes a straight line and a curve. I'll use a radius of 1000. Radius shouldn't go below 450 meters to maintain a design speed of 90 kilometers per hour, but it can go way over 450 meters. So I'll use 1000, then enter. As you can see, the exclamation is no longer there. The road is smooth. Now, I'll draw several parts, several curves as shown. I'm going to go ahead and draw several curves as directed by the center line points. Then I'll join them using a similar method that I joined the first part. So for now, I'll use these 3-point fixed curves to draw my smaller curves along the alignment, the road alignment. So here you can see there is a curve. You can just use your eyes visual observation to see sections that constitute a perfect curve. And that is where you draw your curves. After drawing the perfect curve there is another one here. When drawing this curve, ensure that your alignment doesn't go too far away from the center line, the center line from the surveyor's data, because the road has to align with what the surveyor collected on ground. There's another curve here. Then there's another one here. In sections where the points are in a straight line, you do not have to use a curve. You can use a straight line. And you have to counter check to ensure that your line doesn't go too far away from the existing center lines. There's another straight line here. And then there's a curve. Make sure your straight lines are not too long. There's a maximum length of a straight line that you have to draw. In my case, I'm using the Kenya Road Design Manual. The longest I have to go, the formula used is V times 20, which V for velocity in kilometers per hour times 20, and the answer should be in meters. So in this case, it is 90 times 20, which is 1800 meters. That is around 1.8 kilometer. So my straight line shouldn't be longer than 1.8 kilometer. That is to ensure road safety. Now I'm done drawing the arcs on the straights. So the next step is joining the arcs on the straights. And this is the most important part because any mistake you make will create an error that might prevent the software from running other functions ahead, such as creation of super elevation. Joining these arcs is basically creation of clothoids and transition circles, transition arcs. So in this case, I'll start with this part. There are several ways you can join, so you choose the most appropriate way. If one way fails, you try the other. So for this, I'll try the free curve fillet between two elements and radius. So if I select this and click on the first part and the second part, it will ask me for the angle. I'll choose less than 180. It is a reverse curve because it joins two curves that bend in opposite directions. And I'll use a radius of 1000. It has joined and there's no error, so it's okay. The next section, let me use free curve fillet between two elements through a point because it's quite long and there are several points. So I select the first part, the second part, then a point and enter. The third part is quite long, so I'll use the best fit free curve. Select the first part, second part by clicking on the screen, then I'll click on the bell. Okay, it has worked. There. Oh, I closed the geometric editor. This one has not worked. Let me try another method, the radius one. This one also refused to work. Let me try this. Yeah, this one has worked. In situations like this where all the other joining techniques refuse to work, you'll have to employ the floating curve, where you create a curve that is attached to only one end of the alignment, then left hanging on the other end, where you'll use the other methods to join it to the other end. So I'll choose this and then click here where it ends, so I can join using the other methods here. Yeah, problem solved. This section has too much of a straight line, so I'll draw another straight line here and join it to the other straight line. You can see there's still an There's an error here that I'll have to remove. So that's the horizontal alignment of our rod, and I'll just bring back the elements I did by typing here and isolate. There they are. In our next video, I'm going to show you how to draw the profile, the profile, to the design profile, and the rod corridor. Thank you.